All right, in 6.2b, we're going to continue verifying identities. These are just going to be a little more challenging, so I hope you're up for the challenge. It makes it more fun. So let's just start with number 1. All right, so we have all this business in a fraction, right? So one way to handle this, again, you have all these guidelines. There's lots of ways to start, right? One way I might start on this is a monomial denominator, right? Because it's one term, it's just a big term, it's a long term, but it's one term, and I can split it up, or some people call it sharing the love. So if I split it up, it would look like this. So tangent x over tangent x cotangent y plus cotangent y over tangent x cotangent y. All right, now I can look and see, oh, tangent x will cancel with tangent x. Cotangent y cancels with cotangent y. So what do I have left? Well, I have 1 over the cotangent of y plus 1 over the tangent of x. And if I look at my reciprocal properties, I know that this is just tangent of y plus, and this is the cotangent of x. And look at that. That is what I wanted to get for my answer. So there it is. One step at a time. All right, let's look at number 2. All right, so I have 2 binomials being multiplied. So in my head, it means I need to FOIL. I'm going to start by FOILing. All right, so let's do this. So we'll have secant theta times cosecant theta plus outer, it gives me secant theta. Inner is tangent theta, cosecant theta, and then minus tangent theta. Okay, bleeding into the notes a little bit. All right, let's do this. Now, can we clean any of this up? Well, nothing cancels out looking at it. I don't want to factor it back out to where I was because that doesn't get me anywhere I want to be. So let's just start. Sometimes I just like to start converting things to sines and cosines, and it cleans up nicely a lot of times. So let's just do that. So secant is 1 over cosine theta. Cosecant is 1 over sine theta. That's not much help, right? Don't stop, just keep going. This is 1 over cosine theta minus, what's tangent? Tangent is the sine of theta over cosine theta times 1 over sine theta minus, what is this? Sine theta over cosine theta. Okay, now let's lean back and look for a moment. These will cancel. And what does this become? Well, I can combine these two. So this would be 1 over cosine theta sine theta 1 plus 1 over cosine theta. This is now 1 minus 1 over cosine theta minus sine theta over cosine theta. All right, what do we have here? Well, these cancel out. That's nice. We're getting somewhere. So now I have 1 over cosine theta sine theta minus sine theta over cosine theta. Okay, so to get a common denominator, I need to multiply by sine over sine. And that would give me a common denominator of cosine theta sine theta, right? That would give me 1 minus sine squared theta. All right, well, hopefully you're getting the hang of this and you recognize that 1 minus sine squared theta is cosine squared theta, right? So that means 2 cosines up here, doesn't it? Like if I could rewrite it as 2 cosines, those will cancel out. And what do I have? I have cosine theta over sine theta, which is cotangent theta. Okay, I did not give enough room in the notes for this, but that is where I wanted to go. That's where I wanted to end up. All right, now, apologize for not having a space there. Let's move on to number 3. All right, let's get on with this. So look at this, secant squared y minus cotangent squared pi over 2 minus y, blah. All of that equals 1. Well, this is one of those cofunction identities that we can find on our charts. So let's think about this. Cotangent pi over 2 minus u is equal to tangent. So that helps me know that I can replace all of this with tangent squared. Since it's squared, I would just replace it with tangent squared. So secant squared y minus tangent squared y equals 1. All right, that gives me off the chart. I don't need that anymore. This is a Pythagorean identity rearranged on our charts. Hopefully you see it. And when you find it, you're going to realize that that can be replaced with 1, which is what I wanted, so I'm done. All right. Now, number 4, I want you to try number 4 on your own. We'll revisit it when you get to class. Don't worry. All right, let's look at number 5. Let me kind of help you get started. So this is one of those things where, again, it has a monomial denominator. If I split it up, it might help me see the bigger picture. So I'm going to split it up. 1 over secant theta plus cosecant theta over secant theta minus cotangent theta. Okay, doesn't look very helpful so far, but let's just see. Well, 1 over secant can become cosine. This 1 over sine over 1 over cosine, okay, minus cotangent, right? All right, now if I do keep a tangent, flip it, what am I going to have? I'm going to have cosine theta over sine theta minus cotangent theta. Do you see it? Do you see what's going to happen here? Cosine theta plus this is also known as cotangent theta minus cotangent theta. Those cancel out, and I'm left with cosine theta. Boom. Cleaned up really nicely. Okay, I want you to do number 6 on your own. We'll revisit it in class. But I'm going to do number 7. Number 7 is kind of a booger, but we'll get there. We just take it one little step at a time, show you some skills and ways to handle things, all right? So, tangent theta over 1 plus secant theta plus 1 plus secant theta over tangent theta. So I need a common denominator to get anywhere, right? To get anywhere. So I'm going to have to multiply this guy by tangent over tangent. All right, so where's that going to leave me? That's going to leave me at tangent squared theta. I'm trying to get a common denominator, so I'm just going to put it all over 1. Okay. This one, I'm going to have to multiply by, what, 1 plus secant theta? Oh, that's gross because it's binomials, and I'm going to have to FOIL. So I need to spell it out a little better. 1 plus secant theta. So if I FOIL it out, my first terms will be a 1. Outer will be a secant, inner will be a secant, add them up, I get 2 secant theta. And then last would be secant squared theta. All right? Not crazy about it, but we're getting somewhere. Now, let's do some rearranging. Let's look at this a little bit. This is a Pythagorean identity right here. Guess what it can be replaced with? Secant squared theta. Sure can. So, what do we do now? All right, so let's see what we have. All of it over this. Okay, so I've got 2 secant squareds, don't I? So I can combine those. 2 secant squared theta plus 2 secant theta. Denominator has not changed. But now, hopefully, you see that we can do some factoring, can't we? We can take out a 2 secant theta. That leaves me with secant theta plus 1. Now it's over this. Okay, aren't these identical? Those are the same. Those are the same. It's okay to do that. Now, what's next? Well, 2 secant would be 2 times 1 over cosine, right? 2 2 times 1 over cosine. And now let's think. Tangent is sine over cosine. So if I keep it, change it, flip it, where does that give me? All right, 2 times 1 over cosine. Spread that out just a moment so it's not quite so, okay. If I flip that, I have cosine theta over sine theta. Those cosines cancel out, and I have 2 times 1 over sine theta. What is 1 over sine theta? 2 cosecant theta. And that, my friends, is what we wanted. Look at that. So it's a little gnarly, but we can get there. There is a way to get there. So we'll go over the ones I've asked you to do on your own when you get to class. Thanks for keeping up and not giving up. I know it takes a lot of perseverance, but you can do this.